Hi guys, this is the examples video for lesson 6.6 on series. So first thing we're going to do is expand some series and then add them up to find the sum, just like we were doing in the notes. So let's start by looking at this series. Remember, this guy's called sigma and it stands for sum. This is the sequence that we're adding, the explicit formula for it. This n equal to 1 down here, this tells us, remember, where we start. And then the 4 right there, that tells us where we stop, right? Great, okay. So to evaluate this series, I need to plug in n equals 1, n equals 2, n equals 3, and n equals 4. Okay, so let's do that. I'm going to set it up first and then we'll plug in our n values. So I'm going to leave a space where n will go. Oh, not plus 2. Okay, now let's plug in n. So we get 5 times 1 plus 1, 5 times 2 plus 1, 5 times 3 plus 1, and 5 times 4 plus 1. Okay, now that we've added, we're going to simplify each of those so we know what numbers we need to add up, actually. Okay, so 5 times 1 is 5, plus 1 is 6. 5 times 2 is 10, plus 1 is 11. 5 times 3 is 15, plus 1 is 16. 5 times 4 is 20, plus 1 is 21. Okay, and then we're just literally going to add those numbers up. So I want to add up 6 plus 11 plus 16 plus 21, and I get 54. So the sum of this series is 54. Okay, we did it. We just evaluated a series. Yay! Good job, us. Okay, let's do one more like that. Okay, so we've got a new series. Here's the sequence we're adding. And remember, this bottom part, that tells us where to start. So this time we're not starting at 1, we're starting at n equal to 5. So we're jumping ahead into the sequence a little bit. And then this tells us where we stop. So we're going to stop at 7. Okay, so to do this series, I need a spot for n equal to 5, n equal to 6, and then n equal to 7, and I'm adding between those, right? Okay, so now I'm going to actually plug those numbers in. So I'm going to do the same thing where I leave a little space for n. Okay, so when I plug in 5, I get 2 times 5 minus 6, 2 times 6 minus 6, and then 2 times 7 minus 6. Okay, now we're going to simplify each of those. So if I do that, let's see, 5 minus 6 is negative 1, times 2 is negative 2, right? 6 times 6, or sorry, 6 minus 6 is 0, times 2 is 0. And then 7 minus 6 is 1, times 2 is 2. So I'm adding up negative 2 plus 0 plus positive 2. And if you do that, you should get altogether 0. So the sum of this series turned out to be 0, which is totally fine. Series can be 0. All right, yay, we just did 2 series. Good job, us. Okay, my cat is being really weird right now. I don't know if you just heard him, but he's being goofy. Okay, last two examples, we're going to start with the sequence and then write a corresponding series. So write the symbol for the first 41 terms of this sequence, and we want to know, is it arithmetic or geometric? So what we need to start with is finding an explicit formula for the sequence. Okay, so let's see what we notice here. This is a +3 sequence. Or sorry, not +3. That was completely wrong. Times 2. There we go. Okay, so that's a geometric sequence with this explicit formula. U sub n equals, remember we start with the first term, so 3 times our common ratio, which is 2 to the n minus 1 power. Okay, so let's use that to write our series. So we want to add up that sequence. So I'm just going to put the explicit formula for the sequence right there. And then I want to start at n equal to 1, right? Because it's the first 41 terms. And then I want to stop at 41. And that's it. So if it helps you, we can kind of label these parts again. So this is the start. This is where we stop. And this part is the explicit formula for the sequence. Okay, and again, since this was a geometric sequence, it is a geometric series. All right, so maybe I'll just highlight that it was geometric. Okay, so last one, we're gonna do the same thing, just for a different sequence. So we're gonna write the symbol for terms 10 through 105 of the sequence. And is it arithmetic or geometric? So let's look at our sequence. 12 to 16 to 20 to 24, that's a +4 sequence. So that's arithmetic. And remember, if the sequence is arithmetic, then the series will be arithmetic. I could write that here. Okay, so we need an explicit formula for this sequence. Okay, so remember for arithmetic, U sub n equals the first term, which is 12 in this case, plus the common difference, which is 4, times n minus 1, right? So there's our explicit formula for that sequence. And now we're just going to put that into our series symbol. So we have sigma, that means sum. Then we have our explicit formula. We're starting at 10, right? Terms 10 through 105. So our start is 10. So down here we write n equal to 10. And then our end was 105. So up top we're going to write 105. Okay, and just labeling the parts again, this is where we're starting. This is where the series stops. And I was taking those numbers from this bit, so I want to start at term 10 and end at term 105. And then this guy is the explicit formula for the sequence. All right, that's it. Please complete your check for understanding and then you're done for the day. Have a great day, guys.